Hello there, this is Louis from 3DEVO, and today we have the final episode in our series, How to Recycle Your Own Plastic Waste. Now, if you remember correctly, it all started with Timo explaining to you how to collect and sort the different types of plastic waste. Some of these plastic categories can be recycled, some others can't. In our case, we decided to go with the empty spools from our printers because we have quite a few of them lying around in the building, and again, we noticed that they have a nice mechanical behavior to them. So we thought maybe we could print some nice parts with that. The next step of the process was presented by me, and that was the shredding of those spools into a nice and fine regrind. In the previous video, Timo extruded that regrind into a good quality filament. So I have the obtained spool today for you. As you can see, it is not a full spool. It only contains a few hundreds of grams. The reason is that we wanted to start small. It is good to start with a small batch, in that case a few spools, to experiment with and validate the extrusion step and every step of the process actually, before applying this to a much bigger scale and many more spools in our case. So in that case, because we have successful results and positive results, the step has been validated. Before putting this filament though in your 3D printer, there are a few quality signs you are looking for. The first one is the roundness of the filament. If the filament is round, that ensures an even deposition of the filament on your printing bed. The second feature is an overall homogeneity and absence of foreign particles in your filament, again, to ensure a nice and even melting and deposition of your filament during the printing step. Now, the core aspect here is the tolerance of the filament. That means the deviation of the thickness. A tight tolerance means that the filament is actually quite consistent in thickness. And again, of course, this ensures a very even and good flow during the printing step. It is good, therefore, to have some sort of tool that can measure or assess the tolerance of your filament during the extrusion step. In our case, we made sure that it is very well kept within the industry standard of 50 microns. Keep in mind, this value of 50 microns is very common but arbitrary. Your printer, your machine, might work very well with a filament which has a tolerance of, for example, 60 microns. It is part of the experimental approach. You have to know your machine very well, but in our case we have a good quality filament. It should work quite nicely with that one. That's it. We are about to jump into the printing step. It is an experimental step, just like the extrusion step, so we might have to try, fail and try again a few times to find the right printing settings. Hopefully today it works very well. We are using generic polystyrene printing settings found on the internet, and let's see how this goes. And here we are. Here is our printed item. As you can see, it is a nice but small screw. The printing step went very well, I have to say, but as a matter of fact, this was my second trial. The first trial failed because the adhesion of the part on the bed was insufficient. So what I did was spraying a lot more glue on the build plate. I also raised the printing temperature and I removed the cooling. This way I managed to get a much better layer adhesion. Now this screw right here confirms that it is possible to recycle these empty spools from our printer into a nice functional item. It also validates the last step of the process, the 3D printing part. We have not mastered the 3D printing step just yet because the geometry is quite simple. This was done on purpose because it is good to start small, start simple, learn from your mistakes, just like I did with the bad adhesion of the part on the bed, before applying this to a larger scale or more complex geometries. For example, something interesting would be printing, for example, that famous Benchy boat, but for this we might need or might not need to adjust the printing settings. For a first approach, it is a huge success. This nice printing without any jamming of the printer was made possible because we used a good quality filament. The filament was free of any impurities again, and it was very well kept within a nice and tight tolerance. Also, as a side note, we did not dry the filament before printing it, because just like before extrusion, polystyrene being hydrophobic did not absorb any significant amount of moisture and therefore did not need a drying step. One more thing I would like to mention is that we have conducted this whole study using one grade of plastic specifically, the polystyrene coming from those shredded spools. But other plastics might not behave exactly the same. Here it was quite easy, despite the fact that this polystyrene grade was originally made or manufactured to be injection molded, not 3D printed. In other cases, maybe this step of printing would have been much more tricky. In this case, we were fine. Furthermore, a recycled plastic when being processed does not behave exactly the same as its virgin counterparts. For example, let's assume we want to recycle this piece again. Well, we might have to adjust every step of the process and the settings just a bit more because the plastic would behave slightly differently. That's it, that closes up the recycling loop. That also ends our series of videos about how to recycle your own plastic waste. I hope very much that you enjoyed all of these videos, and I hope that this inspires you to recycle your own plastic waste, because if you find the right settings and master the process, it simply does work. That's it, thank you for watching, and I hope to see you very soon. That was Louis from 3Devo. Ciao!